Fire safety inspections rely on two things: accurate data and unassailable photographic evidence. Without them, it is impossible to verify compliance. Traditional paper checklists and free text notes create severe administrative bottlenecks. They allow for missing fields, illegible handwriting, and disconnected photo attachments, which severely compromise the quality of the data. To solve this, we are going to build the Smart Equipment Checklist. This is a field application designed for the Abu Dhabi Civil Defense, built entirely on Microsoft Power Apps. By the end of this tutorial, you will have a working mobile application. It will dynamically load specific checklists based on the exact equipment being scanned, mandate photographic evidence, and automatically block any incomplete submissions. Replacing a paper process with a strict rules-based digital workflow provides the structured data needed to run faster, safer, and highly governed inspections. Step 1 is setting up the correct sandbox. Open your Power Platform Admin Center and create a dedicated development environment. Name it ADCD Fire Safety Dev. This brings us to a strict rule of enterprise software: never build or edit directly in the live production environment. All development happens here in your dedicated dev environment. Within this environment, we will use Dataverse as our operational database. It provides the relational structure needed to securely store complex inspection records. This diagram shows our core tables. First, create the Asset Register table to hold the master equipment list. Inside, add a choice list named Asset Type, with categories like extinguisher, fire door, and pump. Next, create a check definition table holding safety rules, linking directly back to the Asset Register. Separating the master equipment list from the dynamic checklist rules keeps the application lightweight. This structure allows the system to smoothly scale across thousands of buildings without slowing down. Now let's build the interface. Open Power Apps, create a blank phone canvas app, and add your Dataverse tables as the primary data source. On the main screen, insert the barcode reader control. This allows the inspector to scan an asset tag directly in the field. This wireframe demonstrates the lookup logic. When the scanner reads a barcode, we configure the app to capture that value and store it as a variable named var asset ID. We then use var asset ID to filter the asset register. The app instantly searches the database and isolates the exact piece of equipment the inspector is standing in front of. Next, add a gallery control to the screen. By filtering this gallery based on the isolated asset's type, the app populates only the required checks, like verifying a pressure gauge or a safety pin for that specific item. Below the checklist, insert an Add Picture control so the inspector can capture evidence. In the control properties, set Use Mobile Camera to True. This is a critical security step because it disables photo gallery uploads, forcing the inspector to take a live picture on site. Using dynamic galleries and forced live camera capture ensures the inspector only answers relevant questions and mathematically guarantees the integrity of the field evidence. The primary risk with any field tool is human error. An inspector might hastily submit a form with missing measurements or forgotten photographs. This PowerFX code prevents that by acting as an automated gatekeeper, applied directly to the Submit button. The logic dynamically counts empty required rows. If missing fields or photo IDs exceed 0, it triggers an error and completely locks the button. With the app fully functional, it's time to package your work. Bundle the Canvas app, the Dataverse tables, and the connection references into a single Power Platform solution named ADCD Fire Safety. To deploy safely, export this package as a managed solution and then import it exclusively into your test environment. Before moving to production, run a mandatory field test. Operate the app against at least 10 different physical assets to verify screen load times and layout integrity under real-world conditions. Combining hard-coded validation logic with strictly separated deployment environments elevates a basic digital form into an enterprise-grade compliance tool. The final user experience is seamless. An inspector scans a tag, taps through a tailored checklist, snaps a live photo, and receives a confirmed submission. This provides immediate operational value. Field teams save massive amounts of time on data entry, and reviewing supervisors receive perfectly structured, high-quality data. Now that we have captured structured data, we are ready for the next step of this digital transformation. Use Case 02. In the next module, we will leverage AI Builder to autonomously read the submitted photo evidence and extract exact equipment serial numbers. Building this rule-based, low-code application ensures your data is clean and highly controlled. Mastering this foundation is the strict prerequisite before introducing autonomous AI into critical safety workflows.